Today in class, you develop formulas that can be used to line up results from most likely to least likely to have resulted from a given sampler. For example, for the sampler shown here, one formula that can be used measures the difference between the expected value and the observed value for each column in the graphs shown at the bottom of this worksheet. So, in the first graph, the observed value is exactly the same as the expected value for each column in the graph. So, the sum of these differences is 0 for this graph. For the second graph, the sum of the differences is 2. For the third graph, the sum of the differences is 4. For the fourth graph, the sum is 6. And, for the fifth graph, the sum is 8. Or, in general, the distance of a given result from a perfect result is given by the following formula. Distance, the sum of the differences between the expected values and the observed values in each column. So, in a simulation, this distance formula can be used to determine the likelihood of getting a given results. For example, let's use this distance formula to find the likelihood of getting an 8 as a result from this given sampler. To do this, look at a table of results for this sampler. Then, create a distance formula that sums the differences between observed values and expected values in each column. And make sure that you use the absolute value of these differences, so that you will not have any negative distances. Next, graph the results. Then, run the simulation 1000 times. Finally, adjust the axis on the graph so that all of the results of interest are shown. And, ask TinkerPlots to show the percent of results in each column of the graphs. What this graph shows is that, based on a simulation involving 1000 results, there is only a 14% chance of getting a distance score of 8 or more. And, there is only a 2% chance of getting a distance score of 10. In other words, if a sampler like the one shown generates a result with a distance score of 10, then there is only a 2% chance that the sampler is fair. Next, instead of testing the likelihood that a sample came from a fair sampler, where each result is equally likely, we'll test the likelihood that a sample came from a known distribution, like the one shown in the sampler shown above. To begin, create a table that shows a history of many samples being collected from a sampler that has the known distribution. Then, define a distance formula similar to the one used to test fair samplers, only, for other kinds of samplers, use a slightly different formula that assigns different weights to different columns of data. For example, this formula can first find the differences between observed values and expected values. Then, it can weight these values by dividing each difference by its corresponding expected values. So, the final formula looks like the one shown here. Finally, drag down a divider to investigate the likelihood of getting a result which is greater than some number, like 8, or the likelihood of getting a result in some interval, such as between 3 and 5.5. For example, this graph shows that the likelihood of getting a result greater than 8 is 9 out of 1000, or 0.9 out of 100, or 0.9%.